is about forensic geology. That means we use geological methods to find people who have committed crimes or did environmental pollution. So this is an environmental application of the XRF scanning technology. We have an XRF scanner here at the university, which we will use to identify sources of pollution. So typically, when different industries are polluting the natural waters, they don't want to be discovered, right? That's the whole point of just releasing their heavy metals and other pollutants into the waters. So they do this a little bit secretly, maybe when there's a heavy rain during night, they release it into the heavy water, it's washed away, and it's very difficult for authorities to detect this, because you basically will have to go to all the different water bodies, constantly measuring on site what is in there. So this makes it very difficult to detect, and we have therefore developed a method that we think is very suitable for detecting these kind of clandestine emissions of heavy metal pollution. So we put a resin sachet in the water, so it's an ion exchange resin. So you put it in the water, it releases hydrogen atoms and takes up heavy metal. So that means once it's saturated, it sort of reflects the concentration of heavy metals in the water. So you put it in, leave it there for a couple of days, and then you take it out, and then you take it back to the lab, measure the concentration, and then you know approximately how much pollutants there are in the water. The more chromium you have in the water, the more hydrogen will be released by your resin sachet, and the more chromium will be taken up, and you see that as a peak in chromium, for example. So the equipment is very simple and very cheap. It's basically just a basket like this. In that basket we put our little, like a tea bag with our ion exchange resin, and then we put that in the water for a specific time, take it out, bring it back to the lab and measure it with our XRF scanner. So the XRF scanner is a pretty fancy machine, looks like this. It's almost 5 meters long, uses a very powerful X-ray tube, which is situated here in the house. And so we run the samples from this side through the house where the measuring equipment is, and then it measures a lot of different things. So basically, the first thing that happens is the X-ray fluorescence scanner makes an optical image. That's of course not very important when we have specific individual resin sachets that we are measuring. But this was designed to scan sediment cores. So it scans along the core, it makes an X-ray image, and most important, from the X-ray fluorescence that is emitted from the surface of the sample, we get a spectrum that shows us relative variations in different elements. So what we are going to do, instead of scanning the core, we put a lot of these resin sachets along the measuring sled, and then we run it through, and each one of these is measured, and we get the relative variations in all different elements, basically from aluminium up to uranium. So it's a very rapid method of measuring variations of heavy metals in natural waters. So we did, one of my PhD students, Stephen Pang, we just published this very recently. He did a survey in an area in central Taiwan. It's old rice paddies that have been partially industrialized. So in this area with a lot of ditches and dikes, we put out a lot of these resin sachets and left them in there for some time, and then we took them back to the lab and we measured variations in different elements. So you can see here, for example, lead, zinc, copper, chromium, manganese, nickel, and you can see that here, for example, this is very, very strong peak, suggesting that in this area somewhere here, somebody is releasing a lot of heavy metals. So by identifying the area where these heavy metals are being released, we could then alarm the authorities, and they can go in and do specific measurements. The nice thing with this method is that these resin sachets are very cheap, and they are easy to deploy, so we can spread them out in all the waters here, then just go back, collect them, send them to the lab, run them through this scanner, and very quickly, within an hour, we can analyze 150 samples. So we can cover big areas very, very quickly. So my idea is to put these racing sachets out in Taipei. So you can see here the storm drainage system of Taipei leaves a lot of water into the rivers, and we don't really know who is putting what into these storm drains. So the citizen science part of this is to engage one group of students from the Changdong Senior High School, and they are very eager to help us put these racing sachets in the rivers next to where we are living. So this is where Changdong High School is. I imagine the kids are spread out all over town. They will, on their way to school, they put these sachets out, collect them once a week, send them back to the lab, and then we can measure and update this, present it in a GIS application so they can see which areas are polluted and which are fine. And in an iterative process, we can identify potential sources, and then we can increase the resolution of our sampling in that area to really pinpoint down who is actually polluting our natural environment. So this is the project. These kids and the teacher here, Lori, they are already on board, and we plan to start this project in the beginning of the fall this year. Okay, thank you very much for the room.
Again, if you are more than welcome, no matter you are the incoming students or the current students, as long as your research project is related to the topic, right? Okay. Any other ideas or questions? Otherwise, we invite the next one. According to the schedule, will be the evaluation of the risk of the decline of the coastal tissue.